everybody, it's video note 8.2. We're going to talk about rate some more, calculate rate, and use Hess's law to figure out delta H, and then talk about dilutions and how it relates to rate. Okay, so book connections, please read chapter 10, section 8. Do self-check exercise 10.6. Put it in your notes. Remember the answers are on the back, so you could check the back of your book to see if you're doing it right. All right. So rate is measured in change in concentration per unit time. So we could measure rate in molarity per minute. So, like the molarity of the reactants going away every minute, or the molarity of the products appearing every minute. So another way to write that is concentration over time. Okay, so these brackets mean concentration. Okay, and it's the change in concentration over time. How does rate compare to time? So the rate is always something over time. Time is how long it takes. Okay, so higher rate means less time. Higher rate means less time. Lower rate means it's going to take more time. Okay, so they're related, but both of them, the amount over time is how we calculate rate. So here's some data. So here's some data taken for a reaction, and you can see the amount concentration of this ion goes down over time. So this must be a reactant disappearing over time. So at time 0, there was this much, times 60 seconds, 120 seconds. All right. How does that look on a graph? Well, if we plotted it, it would look like this. Okay. So how do we figure out the rate? Well, there's a couple different rates you can look at. You can look at instantaneous rate is a slope at time 0, okay? Or you can look at it as to figure out the instantaneous rate, you have to take the change in the concentration over the change in time, right? So you can pick any time section. So let's pick this one. In the first 60 seconds, it went from 0.048 molar to 0.042 molar, so we subtract that to get the change. And the time went from 0 to 60 seconds, so we subtract that to get the change. Notice that the rate then is 1 times 10 to the negative fourth mole per liter per second. Remember, mole per liter means molarity per second. So that's the rate at which the reactant is disappearing. Notice this negative sign. If reactant's going away, the rate's going to be negative because the reactant is changing. The rate of the reaction then can be considered the rate of reaction for that time segment. You could also do the rate of reaction for this whole time interval, or this whole time interval, or the whole time interval so that's the overall rate of reaction. Okay, so you could do rate at different points in the experiment. Maybe it slows down, maybe it speeds up. So you can do rate by calculating the change in concentration over the change in time. All right, so here's some more data that you can look at. So what's happening here is that time's going by. N2O5 starts out as 0.02 molar, okay? And then when you start, you have no products because that's what you're making. So these N2O5 molecules start to collide, hit each other, and as they do that, then the concentration of reactant goes down and the concentration of product goes up, okay? So you could figure out the rate at which the reactants disappear. You could do instantaneous rate. So I would take these two over this, okay? So we would do 0.2 minus 0.0169 divided by the change in time, 0 minus 100. So this is going to be, it should be a negative rate because that's decreasing, right? At the same, so then the rate would be that. And then you would calculate it, do the math, right? But then if you wanted to also check the rate, the amount of products increases over time. So I could figure out the rate of production of oxygen gas by taking these two and subtracting and taking the time, that's not the time, and taking the time for that to happen. So here to here. So if I wanted to do the rate in terms of production of oxygen, it would be 0.0016 molar concentration minus 0.00 0.64 molar divided by 100 seconds minus 600 seconds. Okay, so then you would get molarity over seconds as your answer. Okay, do the math, figure it out. That's what you can do, and you could be asked about any point in time. So the overall rate would be start to finish. You could do it in terms of production of NO2, removal of N2O5, or production of O2. That's how you do rate. Let's talk about energy diagrams another time. Delta H is the difference between this line and this line. So the difference from reactants to products is delta H. Products minus reactants if you're using an energy diagram. All right. This is endothermic, so the heat's being absorbed. This is exothermic. But still, the delta H is the difference between reactants and products. Products minus reactants. Okay. One way to calculate delta H was the bonds adding in and the bonds forming. Okay. So we did that in video note 6.2. And that was in the stoic test when we were doing that with delta H. Now we have another way to do delta H, and it's called Hess's law. Okay, so this goes along with example 10.6, page 286 in the book. So you can figure out how to make diamond from graphite. But what we're doing here is we're looking at this as our overall reaction. All right, so we want to know the delta H for its overall reaction. Well, this overall reaction you can get by doing this reaction and this reaction. And what happens is the delta H for this reaction and this reaction, as long as these two reactions add up to this one, you can do the same thing to the delta H's. So if I take the first reaction with the delta H of negative 604 and the second reaction and I add them together, I get Mg plus CuO because the 1/2 O2 cancels out, produces MgO plus Cu. So this and this are the same reaction. So by adding these two reactions together, I can get this final reaction, which is the one we were looking for. So then what do you have to do with the delta H's? Well, I have to add the first reaction plus the second reaction. And you get, let's see, negative 604 plus 155 gives us a delta H for the reaction of negative 449 kilojoules per mole. Okay? So that's how you do delta H. You can add up reactions as long as when you add up reactions, you get this. Whatever you do to these reactions, you have to do the delta H. All I did was add these, so all I did was add those. Okay, now if we look at this one, so we want this following reaction. We want carbon plus oxygen making carbon monoxide. Okay, so this first reaction and this second reaction, there's some way we can manipulate these to get this final reaction. So we have carbon here and carbon there, right? But it looks like we need two carbons in our final reaction. Okay, we have O2 here and O2 here, so but we need carbon monoxide to be in the products. So we can take this whole second reaction and we can flip it. Okay, what do I mean by flip it? I mean reverse it so that says 2CO plus, or no plus, gives you O2 plus 2CO2. All right, so I just flipped it around. If I flip this around, I have to flip this around. So this is going to be flipped, so it's going to be positive 566 now. Okay. So now this reaction is not there anymore. It's this one, and it's positive 566. All right, now so if I were to add these two together, the carbon dioxide would cancel. One of them would cancel. But I actually need two of them to cancel. All right? And then I need the oxygen there to be one on one side, and right now they would cancel. So I have to take this whole reaction and multiply it by 2. If I do that, I have to take this delta H and multiply it by 2. Okay. So let's see what happens. I get 2C solid plus 2O2 gives me 2CO2. All right, so if I take both of these reactions, the CO2s cancel because they're on the same, both one on opposite sides. So now I have 2 carbons, plus this is 2 O2s, but on that side is 1 O2, so that goes down to 1 and that cancels out. So I'm going to get O2. On the other side, I have 2 CO. So this is my destination reaction. Woo, I got it. Yeah. In order to get that, what did I have to do? Well, I had to multiply the first reaction by 2, and I had to flip the second reaction around. So that's what I got to do with the delta H's. So I have negative 393. So I got to put negative 393.5 times 2 is negative 787 plus 566 gives me a negative 221 kilojoules for my delta H. Right? So whatever I do to these reactions, to turn these reactions into the target one, I have to do to my delta H's. So I had to multiply the first one by 2. I had to take the second one and flip it around to change the delta H to positive. Okay, so that's how you do it. All right, so it's all there for you to see. I'm going to erase my scratch and you can see what it looks like. They're written for me. That's all I did, is what you see on the screen. Okay? So the goal is to get your target reaction by adding, multiplying, dividing, flipping the reactions given so that your final, when you add them together, gives you your target, and then you do all that to the delta H's. So I'm going to leave this one for us to talk about in class. Okay. Now we're going to talk about Kool-Aid. Again, yeah, oh yeah. So Kool-Aid is a solution. It has the solute of sugar and flavor, and it has a solvent of water. Okay. Tap water is actually a solution because it has stuff dissolved in it. And 98% rubbing alcohol is a solution, mostly alcohol, but 2% water. Okay, a solution is solute plus solvent. We talked about this before. And the concentration tells you how much of a solute is in your solution. Okay, so a concentrated solution is going to have lots of dissolved particles. Okay, that's what those are, dissolved particles. You can't see them because they're dissolved, but they're all there. The dilute solution is going to have very few dissolved particles. Okay? So when we talk about concentration and affecting reaction rate, we're talking about the number of particles in it. Okay, so because concentration is the measured amount of solute per solvent, you can figure out which one's dilute or concentrated. Dark Kool-Aid is more concentrated than light, so it has more solute. Stinky Lab Partner or not stinky? Stinky Lab Partner, high concentration. Tasteless water, rusty water, high concentration of rust, dilute. 70% SpongeBob fans are fruity. So this is a highly concentrated SpongeBob fan base. This is a more dilute SpongeBob fan base. Okay, so we talked about molarity. Know your definitions. Molarity is said molar, moles per liter. Know it, do it, love it. Okay, so just to refresh your memory, 25 grams of calcium fluoride, right, has to be, we want the molarity, so we have to change it to moles. So we look on the periodic table. It's going to be 40.08, and fluorine is 19.0. There's two of them, so it's 38 plus 40.08 gives us 78.08 grams of calcium fluoride for 1 mole of calcium fluoride. And then with the equals, and we do it. 25 divided by 78.08 gives you 0.32 moles. Right, but we're not done because molarity is mole per liter. So we take the moles and we divide it by 100.150 liters. Move your decimal place, 1, 2, 3. All right, so 32.32 divided by 0.15 is 2.13 molar solution. Okay, just a reminder, I know we did it before, we're doing it again. Okay, so now we're going to talk about dilution. So a dilution is when you take a more concentrated solution, look how many particles are in there in that little bit of water, and you add some more solvent to it, so it becomes dilute. Okay, so this is concentrated versus dilutes for this particular solution because there's more space for the solute. Okay, so you have to know how many particles were in here and how many particles are in there, but what changes is the volume, right? So that means the molarity changes. So you need to know moles before and moles after. Same number of moles in there, but this has more water, so this is a lower molarity, higher volume. This is a high molarity, low volume. So the formula you need to know is MIVI equals MFVF, but we're going to change it to ones, M1V1 to M2V2. Okay. Now we're going to have to make solutions in class. We're going to have to dilute solutions. So you take the moles per liter And then when you dilute it, the moles don't change, just the volume does, which changes the molarity. So we want equal moles, so we have to use this formula to help us decide. Okay, once we find the amount of concentrated solution, all we have to do is add water to it until we get the dilute solution the way we want it. So here's an example problem. It says using a 4 molar stock solution of magnesium sulfate, determine how to make 300 milliliters of 1.7 molar dilution. So let's list out our variables. Okay, I'm always going to do my 1s as the concentrated stuff and my 2s as the dilute stuff. Okay, so 4 molar is more concentrated than 1.7, so I'm going to put it there. And then it says how to make 300 milliliters of 1.7 molar. So 1.7 molar, and we need 300 milliliters of it. But that is 0.30 liters because molarity is moles per liter, so I switch it. And I want to know how much of the concentrated stuff I need to dilute. So I set it up, M1V1 equals M2V2. Plug it in. 4 molar times X is 1.7 molar times 0.30 liters. All right, solving for X, I got to get rid of my 4 molar. Get rid of my 4 molar, so I bring it to this side. So molarity cancels, and we're left with liters. If you do the math for that, you get 0.1275 liters. Now, that's 127.5 milliliters. So what does this number mean? What does it mean? I don't know. It means that we need to take 127.5 milliliters of the concentrated 4 molar solution. Okay. Then add distilled water to dilute it. You're going to get to do dilutions in class. So you have to know how to do the math first to dilute it. Add enough water to get to 300 milliliters. Why? Because that's what we want of our dilute solution. And then stir. Stir. So you mix it together. Okay. Here's another problem that I want you to try to solve. Okay, you try. And then the way you do it is take blank milliliters of 6 molar solution. I want you to fill in that blank. And I want you to fill in the rest of it. All right, so I want you to fill in this blank and then fill in the rest of it to do the problem. Okay. Another one that we'll do in class is how to practice this one. Okay. So try this one. You try. You try. And we'll do in class. You do. You do. Okay. See if you can understand the concept. All right, so to review, dilutions. Moltato says, know your formula for molarity. Moles per liter. Woo! Know the dilution equation. All right, so we're starting with a concentrated solution of a small volume, and we're going to get a dilute solution with a larger volume. When you make the solutions, you don't add a specific volume of water. You fill until you get to your final volume. Okay, so reviewing. Kinetics looks at rate. Reaction occurs in steps. Slowest step determines the rate. Rate is amount over time. Right? You have to be able to calculate that. You can calculate heat, delta H, by adding up the delta H's after you manipulate equations, multiply, flip, divide, etc. Dilution means add water. We have to know how much the concentrated to use and how much total volume to get. Okay, so make sure you do that on that page and know this stuff.